Hello, welcome to our next class, and we are still looking at the topic of algebra. This is the fifth, and I guess it might be the last class we are having with you. And we're still looking at indices. And last time when we ended our class, we had looked at a number of solving the expressions using the laws of indices. And today, I want to start with a number, and I can leave it for you as a workout example. And in case you find any disturbance, you can hit back to our inbox and see if we can be of help to you. And that number, it's DIY. You do it yourself and try to practice your skills. Mathematics is about doing a variety of numbers, and failing does not mean the end of you. So this was time was half into 1 plus x power negative a half plus half to 1 minus x power negative a half. You solve it using the same knowledge of the previous video. If at all you're following it up, 10 over 1 plus x, all this over 1 minus x. You give it a try and see if at all you can solve it. In case you find any disturbance, you can hit back to my inbox and see. I think I'll have the solution ready for you. And now we want to look at something very simple, and that's solving equations involving the rules of indices and slightly some little knowledge of logarithm before we cut over to algebra, to logarithm as our next subtopic, not topic actually. And when we look at solving equations, I might not be able to do each and every number, but I'll try to throw light for you on some numbers, in that when you meet them in your papers, you can do something about them. So this is 4 power x minus a 2, x plus a 1, it's a power, minus a 15, equals to a 0. Such a number, basically our senior 5s and then plus some other institutions of higher learning. But when you recall very well, as we began our classes, we had numbers of the rules of indices. When I had an a power n times a power m, numbers of the same base. What happened was this: we agreed and said this will be our a, so we shall keep the base and have the powers added, m. And when you look at this, it gives me a view of what the 2 power x plus 1 has. So meaning when I have a 2 x plus 1 added up as powers on one base, this means I could have had a 2 power x times a 2. So I'm trying to decompose down that number. And when we look at a 4 power x, I'm going to try to express this number in terms of a smaller number. And then we shall form what we call a quadratic equation later on. Basically, 4 is a 2 power 2. Because 2 times 2 times, it will give us a 4. And then what we have next is just a 2 power 2 x. Yeah, so this is a 4 power x. It still forms back the other one. Someone else can write it as a 2 power x. If at all you still recall that rule of indices, you look at our first video. That still 2 works out. So I will carry these ones and put them into our equation 1 that is given in the question. And 15, we have nothing to do about it, so for it, it shall stay or remain the way it is. So this we shall have a 2 power x all into another power 2 minus a 2 power x times a 2 minus a 15 equals to a 0. So when we have that, the thing we know is, so we can let our 2x equal to y, and you can call this equation 1. You can let it to be any letter you feel like. Someone else can use a k. So this is a y squared minus this is now a y, so it will be a 2y minus a 15 equals to a 0. And then so now this is basically a quadratic equation. So this is a quadratic equation of just power 2. It is not a polynomial. So from there you can use the different formulas. I'll use the formula of body mass for this case as of me. Someone else can try out the other formula of factors and stuff, and you see. So when I use that, it is y equals to negative b plus or minus b squared minus a 4ac discriminant over a 2a, and then this is basically my my coefficient of a is a 1, coefficient of b is a negative 2, then the coefficient of a constant c is a negative 15. So when you look at them, that is it. So when you substitute back here, this means this one becomes a positive 2. So your y is equal to a positive 2 plus or minus, when you substitute them back, this bracket will give you the 64 over 2 times 1. So when you have that, so that means what you have is basically y equals to 2 plus or minus 8 over 2. So either my y equals to 5 or y equals to a negative 3. Hope that's okay with everyone. And now from there we shall get ahead and decompose our number and see whether we can form logarithmic equations, and then we shall use different rules, but basically we shall use the rule of natural logarithm. So we shall consider when your y equals to 5, what comes into your equation 1. Basically you're substituting back to this equation, the one that we had kind of laid together with you, this equation here. So that's the one that we are substituting back into. So we shall have our 2x equals to 5, and introduce the natural logarithm, or the natural log on either side, that is base 10. So we shall have log 10 2 pi x is equal to log 5, and then by the rule of that, it's x is equal to a log 5. It can have a 10, it can be left flat, it's still the same thing, there is no problem. In that now our x is equal to 2.32, either all. Then you have y when your y is equal to negative 3. So this means you have a 2x is equal to negative 3. So when you have log of 10, 2x, so whatever you introduce the other side, 10, 3, we have your x is equal to the log 310 log 10 2. But you notice that when you put this in the calc, it won't exist. So this does not exist. Therefore, this will be our value of x. Thank you. Don't forget to subscribe to our channel. Yeah, a lot of more mathematics classes shall come up. Our next topic will be logarithm. In case of any question, feel free to ask it. Thank you.